Thank you, Shibpur. Thank you for that kind of introduction. Good morning, everybody. Let me begin by thanking Ashish and the institution here for inviting us, giving this chance to meet all of you and talk about something that excites us a lot. I hope it's exciting as well. So, let me introduce myself once again. I'm not sure you introduced me, but I am the Chief Technology Officer of Polaris Networks. We are based in South in Kolkata. And along with me today is Shomi Maiki, who's your very own. I think by now you know she is a graduate of Shibpur 3 years ago. And she's been working with us and doing some very wonderful things, including running many marathons. So, with that, let me start. So, what I'm going to talk about today is emergency communications, how cellular networks can be used for providing communication during disasters and situations where we need extraordinary communications. Before I get into that, let me just get an idea about our audience. So how many of us here are students? So about a dozen students or something like that, and the rest are, I suppose, research scholars and faculty members. And of the students here, how many of you have gone through a course in networking or communication systems? So some of you. And for others, this whole domain of networking and communication would be something new. So I hope that you find this both interesting as well as something that you can relate to. And this is supposed to be more of an informal discussion. We'll have I'll talk about this area and then we'll have a brief demonstration to show you what you could do in your own lab. And if you need to interrupt me at any time, please do so. You don't have to wait till the end for question and answer. It's up to you. You can have the question and answer at the end or during the talk. It's entirely up to you. So, emergencies can be broadly of two types. You can have individual emergencies. For example, you could be traveling in a strange city and suddenly you have your wallet stolen and then you don't know what to do. So that's an emergency for you and you need to communicate with others when that happens. Or the emergency could be a much bigger, widespread emergency. It could be a natural calamity like the earthquake in Nepal, or it could be a man-made disaster like a bombing or a fire at AMRI, that classifies as a man-made disaster. So whenever these emergencies happen, there is a need for communication. Right? What I want to talk about today is more about emergencies which are of a bigger scale. So not individual emergencies, but what happens during, let's say, a fire or a bombing or things like that. So what can we do in terms of providing communication? How can technology help there? Now, these emergencies may occur in an urban area, in a heavily populated area, which already has communication infrastructure. But that communication infrastructure can get overloaded and it may not work. I think we all had a practical experience of that one time or the other. We had an earthquake square in Kolkata. And I think all of you must have experienced that when you try to make a call at that time, the calls will go to most of the time. So that is very natural. So although we have a very sophisticated communication infrastructure, when an emergency does happen, then we find that infrastructure doesn't really work or it gets overloaded. Now the emergency may also occur in a remote area. So when the earthquake happened in Nepal, many of the areas were not connected, but there were many people there and they needed to communicate. So they needed, I think there was an emergency on Mount Everest itself, right? There were people who got affected, they needed to communicate. So this question is always there. How can we provide effective communication in an emergency area? And what we need to handle is two kinds of things. first we have the communication needs of what are called as first responders or the public safety officials, right? So that includes the police, includes fire safety people, it includes medical services. So these are the people who respond whenever there is an emergency immediately. So they are called the first responders. So they have very special needs. They need very quick, reliable, and unobstructed access. Right? The communication has to be very reliable. And when two police officers want to talk to each other, they cannot accept the best effort kind of service. It has to work, it has to have good quality of service. So those are the communication needs of the first responders. And even ordinary users may need communication, and there is a spike in the communication. Right? So whenever an emergency occurs, there is a sudden increase. So that has to be handled. So this is basically the general topic that I am going to be talking about today. We already have critical communication networks in the world. In North America, there is this technology which goes under various names. It's called Project 25, P25, or APCO 25. In Europe, there is this technology which is called TETRA, terrestrial trunk radio. So these are existing networks. They exist today. They are very widely used, and they are mission critical. People depend upon that. And when I say people, I mean the police and other agencies depend upon this. I think even in India, the Indian military, I know, has invested in TETRA, although I don't know whether they're actually using it or not. But I do know that they have that equipment. But in other countries, in the developed countries, these networks exist today. These are all narrowband technology. That means they are geared towards voice calls and very limited applications. And they are expensive, but they do the job. I mean, they allow first responders to talk to each other whenever there is an emergency, and it's very reliable. But what is happening now is people want more. People want broadband. So if you're a fire person, you go to the site of a fire, and then you want to relay a video of what's happening back to your command center. So that the command center can make the right decisions about how many fire tenders do I need to send, what more do I need to do. So having a video, for example, makes the job of the fire person a lot easier. Right? You don't have to say, you can show what's going on. And there are other reasons why people want broadband. Right? So what is the need today is a broadband network which will support not only voice but also other applications, maybe even internet access and video access. So there is a need for such a network. What is happening in North America and in the US since 2012 is that there is a mandate for a nationwide public safety network. This goes under the name of FirstNet. What the US Congress has done is they have passed a law which says that there must be a nationwide public safety network, and they have chosen this technology which is called LTE, and we will be talking about that today. So they have chosen this broadband cellular communication technology, LTE, as the basis for this nationwide network. They have allocated money for it, like $7 billion. They have allocated 20 megahertz of spectrum for this network. I think all of you know how extensive spectrum is, right? So I don't know if you know what is the cost of 1 megahertz of spectrum. That's in countries like India, it's a few thousand crores, right? So multiply that by 20. So anyway, the point is it's a very serious effort. And so they are rolling out a nationwide public safety network. And that is going to be based on it. So now let me LTE. And I think today it's probably a term that you must have heard. Is that a fair assumption? How many of you have not heard of LTE? No, that's good. So 3 years ago it was very different. Nobody had heard of LTE. Today at least at the minimum everybody's heard of it. And probably you have used it. Right? So how many of you have used LTE? So that not too many, but still some of you have used. So you know that Airtel provides LTE in Kolkata, and they have been doing that for a few years now, So it's rolled out in India as well. So that's a good thing. So what I'm going to talk about is the LTE network and tell you how it's suitable for emergency or critical communications network. The term long-term evolution, so this technology was standardized by this body called 3GPP, which stands for Third Generation Partnership Project. This is the same industry body that invented the technologies like GSM and UMTS that we are more familiar with. Right? All of us use GSM phones, and we use 3G, which is UMTS. So the same body, 3GPP, standardized the next generation of cellular communication. So that is why it's called long-term evolution, because it's an evolution from GSM and UMTS. It's called a 4G technology, fourth generation technology, and it's called fourth generation because of these reasons. Right? It's high data rate. So the expectation is that if you have a single cell, right, you know what a cellular network is, right? It is made up of, we see towers all around us, so I think I don't need to explain that. So if you talk about a single cell, the expectation is that a single cell must provide data throughput of at least 100 megabits per second downlink towards your phone and about 50 megabits per second uplink from your phone. And that is the minimum. And if you have multiple sectors in each cell, then it can increase. And to qualify as a fourth generation technology, the expectation is you should be able to provide, you as the network should be able to provide 1 gigabits per second of data throughput. That's the kind of expectation from the network. Each user may not get 1 gigabits per second because that throughput or the bandwidth is shared between multiple users. But that's the expectation from this technology. It's a low latency technology. That's very important for applications like video gaming. If you are browsing the internet, then the latency or the time delay in communication doesn't matter. But if you are playing a game with somebody, then it matters, right? You might be shooting each other. So it requires that you want to evade. You better see that on your screen very quickly. So the latency has to be very small. So in LTE, in a fourth generation technology, the expectation is that in what is called as the control plane or signaling plane, the latency should be less than 100 milliseconds. The time for one packet to go, there's a to and fro, that should be less than 100 milliseconds. And in the data plane, where the actual data goes, it should be less than 10 milliseconds. So typically in LTE, latencies are on the order of 50 milliseconds. And it's an all IP network. So many of you will be familiar with the circuit switch and packet switch networks. So the older technologies like GSM and UMTS, they are circuit switch. That means voice goes as voice and data goes as packets, and the two are separate. But in LTE, it's one network. It's an IP network, Internet Protocol network. And all data, whether it's voice, video, everything is packets. So that is what we mean by a fourth generation technology, and that is what LTE is. And this is a continuous evolution. So from fourth generation we go to LTE Advanced, which is fifth generation, and we have more and more which is coming up. Where the industry is today is 4G is deployed fairly widely. In the advanced countries, I think you have pretty much universal coverage. You go to any part of the US or Western Europe, you will have LTE coverage. In India, you probably won't have LTE coverage everywhere. I should probably qualify that. Like, the US is a very big country, right? So when you say that you get LTE coverage everywhere, I don't literally mean everywhere. What I mean is where there are people, so the heavily populated areas, that's where you get LTE. If you go to in the middle of nowhere, like in Wyoming, you won't get LTE. But still, the point is it's very common. It's very widespread. It's no longer a new technology. Now, the reason this LTE became very so powerful was because of all the advances in electronics and communications engineering. So, so you may be familiar with things like orthogonal frequency division, multiplexing, and orthogonal frequency division, multiplex access. So, I won't go into all of these details today, but these are some of the features that make this technology powerful. So you can, it's supposed to be a very spectrally efficient technology, which basically means how many bits of information can you stuff in every megahertz of spectrum. So using LTE, you can do it's 2.3 or 2.5 bits per megahertz per hertz. So that's considered very spectrally efficient. And the way they get to that is by using these advanced technologies. So there is orthogonal frequency division multiple access. There's another technology called single carrier frequency division multiple access for octave. There is a technology called MIMO, multiple input, multiple output, where the idea is that instead of having a single antenna between the receiver and the transmitter, we use multiple antennas in a very sophisticated kind of configuration. But we use spatial multiplexing essentially. We have multiple antennas, and so the effective throughput will increase. Whatever you could get by one set of receiver and transmitter, now because we have multiple receivers and transmitters, your throughput can double or triple or increase. And then there is also this technology called carrier aggregation, which is, I don't think it's rolled out so commonly, but it is. It will be necessary to go to 1 gigabits per second. You know, today, LTE can offer 100 megabits per second or maybe 200 megabits per second per cell. If you want to go to 1 gigabits per second, you have to do something like that. So one of the things you can do is what is called as carrier aggregation. And it's not very difficult one. It's a very simple concept. If you want to use one slice of spectrum, let's say 10 megahertz in the 21 megahertz band, so you can get some amount of data throughput. Now, an operator may own spectrum in 21 megahertz, which is band 1, and it may own some spectrum in another non-contiguous area. So, 21 megahertz and maybe 700 megahertz. Right? Now, you want to use both bands to offer service, but to the end user, it should look like one network. So, what you're doing is you're aggregating different bands of frequencies and providing a unified service over these multiple bands. That essentially is carrier aggregation. So, I don't know how whether you keep up with the news about spectrum auction, but you might have seen that spectrum with lower frequencies is more expensive. So 700 megahertz, 900 megahertz is more expensive, 21 megahertz is less expensive, and 2500 megahertz will be even less expensive. So operators will buy whatever they can buy. And then whatever they have, they want to offer a unified service over that. So that's carrier aggregation. And that's a more recent capability in LTE. I just wanted to show you a slide on how an LTE network looks like before we get into the emergency communication part. So in any cellular network, we have basically three parts. We have the devices or the user equipment to start with. So these are things like your phones, these smartphones. It can also be laptops with data dongles. And some of you might be familiar with data dongles that you can put in a laptop and connect to the internet. So this is basically your user equipment, and that connects using a radio interface, a radio link, to the tower or to the base station. In LTE we call that node B. E is for evolved, so it's a node B. Various reasons. So that's basically your tower. It's got a radio interface, and that tower is connected using what we call as a backhaul connection to the operator's core network. So this EPC stands for Evolved Packet Core. This is the core network, and this network allows you to provide all kinds of services to your users. For example, there is an element called MME, which authenticates the user, it can authorize the user. It can handle mobility. The user is moving from one cell to another. The network needs to keep track of that. So the MME that handles that. Then there are other elements here. For example, there is the PCRF, which stands for Policy and Charging Rules function. So it implements policies decided by the network. For example, the network the operator may want a policy like this, that if you have a high priority user, like a policeman, if that high priority user wants to access the network, then you want to preempt the low priority users. So that's a policy. So policies like this can be implemented in an LTE. And so these are all the elements that make up what is called as the Evolved Packet Core, EPC. And this EPC is connected to what we can call as the packet data network. So for example, the internet. So from a smartphone, if you want to browse the internet, your smartphone connects using radio to the base station. The base station is connected using some link to the packet code, and the packet code connects to the internet. And it may not just be the internet, it could be our analog phone network, for example. So from your smartphone, you can call a landline. So this packet code will have the functions to allow you to connect to landlines. It can have other kinds of connectivity as well. Like for example, if you think about the police department, the police department may have a command center, right? And all the police who are out on the field, they want to communicate with their command center. So in an LTE network, they would go to a base station or the tower, and through the core network to connect to their command center. So that is what our network topology looks like. Now, let me just show you how the network usage can change during an emergency. So this paper basically talks about quantifying the change in call volume when an emergency happens. So over here you see different kinds of graphs. So on the x-axis you have the time, and on the y-axis you have the change in call volume. So this is delta V T is basically the change in call volume with respect to time. And what these authors did was they divided the users into two groups. The group of users who are affected by that emergency, and everybody else. So you might see G0 and G1. So G0 is the group of users who are affected by the emergency. Okay. If there's a fire and people in the building. And G1 is all the other users. And what they're saying is that it is not only the G0 users who want to talk more, but it's also the other users. Right? So we may have an earthquake in Kolkata, but our family and friends in Bangalore will call us up. So there is a spike in call volume everywhere. So what people do is they try to study this, they quantify this, and then they try to design networks to meet these kinds of requirements. Let me now talk about what are the features in an LTE network that make it especially suitable for emergency communication for the public safety users. So the first feature is that of an emergency call. This is something that people in the Western world take for granted, but for us it's still something that we wish for. Except when you are in an emergency, right? I mean, I give this example of you lost your wallet or something even more serious. You're walking on the street and you are accosted by a ruffian. And so what do? You would love to do something, right? So in some cases you may not have time to take your phone out and call somebody. In other cases you may have some time. Now you would like to place a call as quickly as possible. So as many of you would know, in the Western world you would just dial an emergency number. So in the US it is 911, in other countries it could be 411. And the remarkable thing about an emergency call is, first of all, anybody with a phone can make that call. Like you, from India, you would be traveling to the US or Australia. You don't have you're not a US subscriber. You don't have an account with that operator. But you can make that emergency call. You may even have a phone which does not have a SIM card. It is just a phone without a SIM card. But you can still make an emergency call. And it gets very high priority, as opposed to normal calls. So that is a way of life. It's been a way of life for the last 20 years, 25 years. Going back to analog phone days and then going to GSM and all of that. And it's become better and better over the last couple of decades, but people there take it for granted. That if I have an emergency, if my pet kitten has climbed up a tree and can't come down, it's an emergency, so you call up 911 and they come and help you before the kitten falls down and hurt itself. So it could be something as simple as that. It could be something more important. I can tell you a personal experience from 20 years ago. So I was working as a contractor in another company, So I was not an employee of the company, but a contractor, and I was working. I went there on a Saturday, and I didn't realize, but I set off the security alarm because I didn't know all the rules and regulations. I used my key, access card, and entered, but I did not punch in the right code. So I set off the alarm, and I was all alone in the office. I didn't know what to do. I dialed 911, and I said, "Look, I'm not a robber. I accidentally set off the alarm." So within 2 minutes, a police person came and he verified my credentials and he let me go. So the 911 call made sure that there was no undue alarm. So the alarm did go off, but I used 911 to save myself. And it just worked. Don't you wish that you had something over here? I mean, we have many reports of emergencies in Kolkata, and people wishing to call somebody, they just don't know what number to call. The police usually provides you a number, 100, or even 100 work. And so clearly the need is there, right? Now LTE provides this feature, and it's not a new LTE. It was there in GSM, it was there in UAVs, and it's there in LTE also. There is another thing called location reporting. So when I made my 911 call, I didn't have to tell them where I am. I just picked up the phone and said, "This is the situation." They knew where I was because they could determine my location, because of my phone call. So this is location reporting, and there is a whole technology behind it. Like how does the network determine your location? Now, if you have a fixed phone, it's very easy, right? Because they know where that phone is. But if you have a mobile phone, how do they know where you are? So they need to track you. If you have a GPS enabled, then they can use GPS to track you. But what if you don't have GPS enabled? They can still track you. And so there's a whole technology behind that. And it's very interesting, especially for electronics engineers and physics engineers. So LTE supports a very sophisticated form of location reporting, which could be assisted by the phone, or even if the phone is not cooperating, the network can still find your location through all kinds of triangulation methods and all of that. So that is there. And you can imagine an emergency that's very useful, right? Because you may either not know where you are, or you may not have enough time to communicate. It's much better if the network can figure out where you are on its own. It can also be used for non-emergency use. Like you go to a new city and you want to find out restaurants in that area. So you can just open an application, find the nearest restaurant. You don't even say where you are. And we have these taxi services like Uber and all, right? You don't tell Uber where you are. You just open their app, they know where you are. Right? And it is through these location reporting services. And there is a multi-billion-dollar company that is built on location reporting, fundamentally. Another feature is something called CMAS. So whenever there is an emergency, like an earthquake, we all call each other, right? Oh, was there an earthquake? Yes, there was an earthquake. We try to find it. Now, wouldn't it be better if we could get information sent to us in a nice and easy way? So basically, this feature called CMAS allows the public safety agencies to send alerts to the whole population in a very efficient manner. So suppose there's an earthquake, so they can send an SMS or other type of information to all the users in an efficient manner, so that it doesn't load the network much. And so it could be during an earthquake, it could be during a tsunami, it could be the president of the country decides that there's an emergency and you want to communicate with the whole nation, so you could use that. So there's this whole technology built to support that. Then there's in the LTE network we have a concept of user types. So there are normal users and priority users. And why do we have that? It is because if there's an emergency, then certain users are priority users, right? The first responders. See, the thing is, when you have an emergency, the emergency may be in an area where the only network available is a commercial network. There is no other network. Let's say Airtel has a network in that area, and there's nothing else. So now the police and the fire safety people or whoever, they need to use Airtel's network. But when the emergency happens, they need priority access. Because the cell or the tower can handle only, let's say, 200 subscribers at a time, 200 users at a time. Now, the network can get overloaded by 200 regular users, and then the police won't be able to talk to each other. So that should not happen. So there is the concept of priority users and the LTE network can give prioritized access to those users. And the technology allows normal users to get preempted. So if they're already talking, they will get bumped off. So they will get preempted, and priority users can get access. There is a related concept that is that of access class. It's not the same as priority. It's whenever the priority comes in when you have when you're already sort of connected to the network and then you want like a service. But how do you get connected to the network? So many of you or all of you might be familiar with concepts like CSMA or I don't know, but like whenever you have a communication network and the medium is shared, there is always the question of how do you get access to that shared medium. So if you're all in the same room, then I can get access by just shouting, right? And then forcing you to quieten down. But in a communication network, that will not work. There has to be a technology that supports some users getting access to that shared radio. In this case, the radio where channel is the shared radio. So in LTE, there is a technology, there is a concept called access class, and your phone has a SIM card, and the SIM card has an access class built into it. So normal users will have access class 1 to 9, I think, and there are classes reserved for security forces and for emergency services. So where the network will give them priority access for the shared radio medium. And if you understand how technologies like CSMA and all work, then you would understand this whole concept of contention and getting access to that shared radio medium. There are a few other features that make LTE very suitable for emergency networks, and these are defined more recently. So, the LTE as a technology was first standardized in the 2008 kind of time frame. That's the time frame in which the PGPP standardizes technology. More recently, like around 2012, certain features were added into this LTE technology to make it more suitable for emergency networks. So one is goes by the name of proximity services or device-to-device communication. So usually what happens is when two users want to talk to each other, they don't talk directly. They will be sitting next to each other with our phones, but if we want to talk to each other, we don't talk directly. Our phone will send data to the cell, to the tower. The tower will send it to the core network, and the core network will use the help of either the internet or an IIEST network or the PSTN network to route your call back to the receiver. So this is the normal communication. But when an emergency happens, you may want this communication to happen directly for various reasons, right? I mean, one reason is you will put less load on them because your data or your call is not going all the way through. You want to talk to somebody, and you're all in the same area, like in the same building or in the same geographical area. So wouldn't it be nice if you could talk directly to each other? And with the old walkie-talkies, you could do that. But walkie-talkies have their limitations. So we want to have something similar. And so this is one example of direct proximity service. Now you can have variations of this. For example, it may not be just phone to phone. It may go through the cell, but not through the core. That is also possible. Because it depends upon the capability of your terminal, of your user equipment. Your user equipment may not be able to handle direct device-to-device communication. So in that case, you can go through the cell, but don't go through the whole. So there is a whole technology behind this to enable this. For example, you want to be able to discover the phones which are in your area automatically. You don't want to. Suppose there are 25 policemen all in the same area. And they all rush. They don't want to spend time configuring their device. Okay, there are 25 of my colleagues in this area and I want to talk to them today. It should just happen automatically. You should discover those 25 otherwise automatically, set up the communication. So there is this whole technology standardized in the 2012 release for this. Another happened. So, one person may want to talk to multiple people in the group and switch roles. So many times this application is called push to talk. because then you had those walkie-talkies. Whoever wanted to talk would push a button and then talk. And then when you are done talking, you release your button. And then you listen. So that is basically push to talk. So that's a very standard application for emergency communication. It's supported by ITRA and all P25 and all the existing. So the question is, how do we support group calling, push to talk in LTE? Now, LTE being an IP network, you could develop any application on top of it and the network will support it. Right? Uber is an example. So Uber is an application. Right? It can run on any network. It could be GSM, UMTS, LTE. It's what is called an over-the-top application because it does not depend upon the network itself. It runs over the top. So push to talk or group calling can be implemented as an over-the-top application, but then you don't make the best use of the radio spectrum. So if you want to use to make good use of the radio spectrum, then it's better to have the underlying network support that application. So in GDP release 12 of LTE, there are some extensions to support this group calling concept. And for lack of time, I will not be able to go into some of the details. But these are some of the things that agencies all over the world are very interested in making real emergency communication networks. So this is whatever I've been talking about has sort of gone beyond the research stage and more into the implementation stage. There's still a lot of research going on, but these are some things which are already rolled out or people are in the stages of rolling them out. I wanted to talk about, and that is this concept of deployable network. So we can give two examples to motivate the need for a network that can be deployed. So one example is, say if you have an emergency in a remote area. Right? So there is a flood which affects a very rural part of the country where we don't have a communication network. So now we want to send relief workers there and they should be able to talk to each other. So how do you set up a network? So one natural way of doing that is to take the network with you. Okay? So you can put it in a truck and go there. Okay? Now, for example, what happens if it's in the top of a mountain? Okay? Earthquake in Nepal, right? Mount Everest. So you can take a helicopter and get it over there. Or if possible, the relief workers can take the network on their backpack. Now, this would be nice, right? I mean, this is what we would like. Now, this is something that has become possible now and was not really possible earlier. Why? Because of the earlier technologies like GSM and UMTS, the equipment there was really very bulky. Like the base stations that you must have heard of, they are like equipment which is the size of cupboards. Even the core network equipment, show you the network diagram with all these different elements. So each part of that network equipment is very big, very bulky. You can't really take it around. So it's very big. With LTE, things are getting smaller and smaller and smaller. So now you can actually have base stations which are this small. Now, of course, the coverage and the output power will depend a little bit on the size. So if you have these very small base stations, the coverage may not be very large. What are called as macro base stations can cover an area which is say several kilometers in radius, 3 kilometer radius, or even more, depending upon the power output from the antenna. You know, the high gain antenna have a lot of coverage. But if you want to have a smaller coverage, then you can have a smaller base station, and they can really fit in your pocket or in your backpack. So they are this small, and the cost is also covered. So the macro base stations would typically each would be like $50,000 US. The smaller cells, the small cells as they are called, will be much cheaper. So again, it depends upon the cost would depend upon the coverage area. But if you don't want a very wide coverage, you can buy a small cell for $1,000 US. And if you want to buy in bulk, it will be like as cheap as $300 US. Today, you can place an order for a LTE base station, it will cost you $300 US. It's much less. So it makes sense to give every relief worker, every policeman their own network. So the idea behind deployable network is that you have the base station E node D and the core network all integrated in a small form factor. I described one of the use cases, which was you want to provide coverage in a remote area. The other use case is even in a heavily populated area. When there is an emergency, you need increased capacity because the network goes down just because it's overloaded. So for some time, you want to increase the capacity of that. Maybe for a few hours, maybe for a few days, and that emergency can happen in different cities or different towns. So it would be nice if you can increase the capacity by rolling out a network when the emergency happens. So that's another use case for a deployable network. And this is something that is very real today. Deployable networks are there. You can, one point that is mentioned here is that if you have a deployable network that allows the people on the ground to talk to this cell, but then those users, they want to connect to their command center or they want to connect to the internet. So you need a backup connection. So that can be a satellite connection. If just go back to this diagram. So the deployable network would include the EOT and the EPC. So this is on the truck, and the users are talking to each other. But if they want to access the internet, then they would use the backhaul connection. And this line that you see here can be a satellite link. What is exciting? Another thing that is becoming exciting now is this concept of machine-to-machine communication. So we are all used to users, human beings communicating with each other. But what is now becoming increasingly possible is for all kinds of machines, all kinds of things to talk to each other. Okay? For example, you could have sensors, right? You could have every building, every room can have a temperature sensor, a light sensor, a motion sensor, all kinds of sensors that you find in your phone. They're extremely inexpensive. Right? Like today your phone has all kinds of sensors that you don't even know what sensors you have in your phone. They're so inexpensive. So you could actually have these devices everywhere, and they could all be networked. So every device is an IP address. It could be an IPv6 address because there are millions, if not billions, of these devices all over the world. And they're all connected, so they're on the internet. Each of them has a network. I know major operators in the US, operators like Verizon, who are actually working on this kind of a countrywide network, which the idea is that that network would allow things to talk to each other. And those things could be sensors or anything that, it's up to your imagination, or what can you do. So the idea is for these machines, devices, things to talk to each other using LTE. So they're all LTE. The costs have come down so much that you can have an LTE radio in 4-way devices. And they're all networked. And the technology is designed in such a way that you can get the best out of it. So, for example, battery life would be a very important consideration, right? Your device. You don't want to keep changing the battery every day or every month. You want the battery to last for 6 months, 1 year. So what kind of communication technology will allow that? So many of these operators are doing some research work and coming out with very innovative networks to make that possible. So they are inventing their own network to do this. That's very exciting. I think it's the term you must have heard about, the Internet of Things. And it's very important for emergency communication just because instead of rolling out a network when the emergency happens, you just blanket the whole country or a big area with sensors of different kinds. And then when the problem does occur, you have something. So, for example, you could have a video camera attached to a sensor. And then when an emergency happens, the video camera comes on. And then it starts sending a video feed. So you can have some intelligence based on that. So video is, of course, requires broadband communication. But the sensor itself does not. So you can combine the two things and then use LTE for both, for low throughput sensor as well as for high throughput video. So now the possibilities are endless. So this is really what I wanted to cover in my part of the discussion. If you have any questions, we can take that. What we would also like to do is follow up with a brief demonstration going to discuss. Do you have any questions? The idea was behind this our demo is that if you wish, you can have an LTE network in your lab. If you want to learn about it, if you want to do some research work in that area, and to do this. I know there's a military college in Indore. It's in a place called MHOW. They have set up an LTE lab with our there. This is a military college. So this is where all the soldiers, etc., who are part of the signal force, they go for training. So they actually set up an LTE network where they've got all kinds of devices like smartphones or tablets. They've got small cells in their lab. They're also going to be rolling out an outdoor network. They have got core networks, they've got IMS networks. So now they can actually try things out. And initially it's a learning thing, but hopefully this will be a research thing. So I hope this demonstration will give you some idea of what you can do with it with a laptop and